start off with is, tell me how many of you have already stepped into machine learning, or you have no idea what machine learning is. Just tell where do you stand, and it's absolutely okay even if you're say you have no clue what machine learning is. What is ML? Okay, I'm coming to that. That's the entire session what we have. So guys, tell me where do you stand? Say on a scale of 1 to 10, where how would you rate yourself on machine learning? And it's absolutely okay even if you're 0, because we have a session for from the scratch. So how do you rate yourself? Because I just want to understand the crowd. That will help me deliver in a better way. Okay, I got 0, 4, 1, 5, I guess. Okay, 1, 0, 0, 0, which is absolutely okay. Okay, I have a old student Samruti. Okay, 2011. Okay, on a rough scale, I can say people falling from 0 to 5 maybe. So maybe zeros, a lot of zeros, and then ones and twos, which is absolutely okay. So I have a session today. I'm gonna be with you guys for the next maybe 1 hour plus few more minutes. So just let's get started without wasting any time. I'm expecting a lot of interaction. I'll be asking you a lot of questions, and not anything got to do with machine learning. You will witness that. So guys, I'm sharing my screen. Just let me know if you're able to see the screen. You can put a simple yes message if you're able to see the screen. It says you're presenting your screen, so it should be on. Yes? Okay, excellent. Okay, so here, this is a WPS office. Where do I see? Okay, here it is. So I hope you guys can see my questions. Sorry, see my screen. For any of your questions, if you have any questions, you can simply post the question, because in the middle, I will always come back to the screen and look at the chat box. If you have any questions, I'll definitely answer them. Or if you want to ask me questions, probably at the end, we will have a window for the question and answers. We can have a discussion over there as well. Okay, so here it is. Tell me what, okay, first of all, what do we have here for the next 90 minutes? So this is what we'll be discussing. What is machine learning? Why is it even required? Application, types of machine learning, terminologies. What are the general steps which are used to build a machine learning model, an example of machine learning. So we'll be looking at these things. Now, tell me what comes to your mind when you look at this particular picture. I want your answers over here. So I'll have to switch to the screen. Samruddhi says I can't see it. Guys, are you able to see my screen? Do we get to minimize this Google full screen? No, it's so not full screen. I want that small window somewhere. I think it's possible on Zoom. It's not possible over here. Anyway, tell me what comes to your mind when you look at this particular picture. A very simple picture. It could be anything, guys. Whatever comes to your mind, even if it sounds absolutely crazy, it's absolutely fine. But I want you guys to answer over here. What comes to your mind? Anything? No answer? Let me show this picture again. There's this human. There's a CPU, some monitors, some bits, ones and zeros. There's some sort of pipe. It looks like a circuit. So what comes to your mind when you look at this picture? Giving machine some intelligence. Very good answer, Avit. Robot, automation, machine understandable language. Okay, very good. Anything else apart from that? AI, very good. Okay, so whatever you guys are saying, it's pretty close to what I'm expecting. So this picture on a very high level, it speaks something got to do with artificial intelligence. Just observe over here. There's a human. Humans tend to have natural intelligence. You guys know about that. Humans have natural intelligence, and here it's connected to a computer, and this intelligence is somewhat getting transferred to the CPU. How is it done? All of that we will, it's just one simple picture that I wanted to start off my journey with, this particular session with. So this, represents artificial intelligence in some manner, but the problem is whenever I speak about artificial intelligence, whenever I say AI, the term AI to my students, this is probably what comes to students' mind. What are these guys? If you look at these picture, there's so many pictures over here. What comes to your mind when you look at this picture? What comes to your mind when you look at this picture? What are these? I'll have to switch back just for the answers over here. Robots, very good. Okay. And one thing which is common in all these pictures, all these movies is there's some sort of artificial intelligence which is shown in the movies. You guys will agree with me for that. It could be anything. Some sort of artificial intelligence and show there's some robot who has some intelligence. Now there's a very big misconception. I want to start this particular seminar, this particular webinar with this topic because students tend to think that artificial intelligence which is available in today's world is something like this, which is shown in the movies. But then, to be very honest, whatever is shown in the movies, we are still very far from that. Whatever you see in, say, a Robo movie or there's so many Terminator movie for that matter. Whatever you see, it's still very far. We have still not achieved that kind of artificial intelligence, but at the same time, we have made a very good progress. Also, we'll be looking at that. So until now, I was talking about artificial intelligence. I've not spoken about machine learning. So next question that I want to ask you guys is, do you think these two are two separate entities or they mean the same thing? Or do you think they are separate entities, but there is an overlap between them? So what do you think is the difference between artificial intelligence and machine learning? Just give your own answers. It could be absolutely, you can join the meeting from your mobile to check chat. Actually, yes. Let me join the meeting from my phone in order to see the chat. Just give me a minute, guys. Meanwhile, you can answer that question. I'm just joining a meeting. Okay, I've got the chat. Yes, let me go back to the screen. Guys, tell me what comes to your mind when you look at this particular picture. Why do we need ML and where is it applied? I'll come to that question, Mohammed, in some time. Yeah, I can give recommendations, but ML models are trained to give prediction outputs. Okay, so basically, whenever I tell about artificial intelligence or if I'm speaking about machine learning, people usually, I mean, if they have not got into this particular field, this is one of the idea that people usually tend to have, including me back then when I started the journey in, say, machine learning or AI. I used to think both are actually same. In some way, they are same, but then machine learning is actually a subset of artificial intelligence. If I show you this particular picture, this will give you a better idea. If you can see, artificial intelligence is a bigger circle and machine learning is a sub part of it. So apart from machine learning, there are other ways there are other ways in order to achieve artificial intelligence. For instance, cognitive computing, natural language processing, and there are different ways, but machine learning is one of the most popular way through which you can actually achieve artificial intelligence. Okay, so this is something that I just wanted to give you an overview of before we get into machine learning. So whenever we are discussing about machine learning, it's not that we are not discussing about artificial intelligence. Even if you're discussing about machine learning, indirectly you're actually discussing about artificial intelligence. That is how it is. Okay. So next thing is, what exactly is machine learning? What exactly is machine learning? So machine learning is an application function of artificial intelligence that provides systems ability to automatically learn and improve from experience without being explicitly programmed. I know just reading out the definition will not help understand. In fact, I hate definitions. I don't like giving definitions to the students. This is just for the formality that I've put it over here. Don't worry. I will come back to this definition after giving you one scenario. Okay, after giving you one scenario, let's understand one scenario and then let's come back to what is machine learning. Okay, so is that cool? Can we go ahead? Can you put a simple yes message if you can go ahead? I like taking acknowledgements from my students. Okay, excellent. So why is machine learning even required? So let's understand the situation and then let's come back to the definition. That will help us understand the definition much better. Okay. So tell me what comes to your mind when you look at this particular picture. Just observe this picture. I'll tell you what exactly am I talking about, but you try guessing what exactly is this picture. No answer? What anything, even if your answer is absolutely crazy, it's fine, guys, but I want you guys to answer. Okay, Yash says it's social media, Aditya says it's restriction. Can we combine these two answers, what Aditya and Yash is saying? Can we say it's restrictions on social media, basically? So I've got two answers, restrictions and social media, right? I don't know if you guys have witnessed this, but then when I was in college, I had a Wi-Fi connection from the college, but a lot of sites in my college were blocked. They were not available to us, like entertainment sites, YouTube, Facebook for that matter, Instagram for that matter. All these sites were blocked. Have you witnessed anything like this in your colleges, where you connect to your college Wi-Fi and everything is blocked? Yes. I'm pretty sure most of you might have. In fact, in my very first company also where I had joined, I had restrictions over there as well. So, probably any entertainment sites were blocked. So Wikipedia used to open, things like, any information sites used to open. Now, let's assume a situation where, say, you are a system admin. You're a system admin, and one of the tasks that you have is you'll have to write a simple program which will allow or block the sites. As simple as that, which will allow or block the sites. And let's try understanding the situation a little better and assume we have only 100 websites in the entire world, which is not realistic, obviously. But then let's just consider that, just assume that we have only 100 websites in the entire world today. Then the task for the system admin, it's going to be very easy. If URL equals www.google.com, allow. If URL equals, say, www.youtube.com, block. If URL equals www.wikipedia.com, allow. Something as simple as that. A simple Python script or any other language script for that matter will do. Correct? Tell me, are you understanding until here? If we had only 100 websites, it's going to be very easy, right? Now, let's assume the situation that we have in the world right now, which is thousands and thousands of websites, new websites are coming up every single minute. We already have few millions of websites. Apart from that, there are few more websites coming up, like, few thousands of websites coming up every single minute. That's the actual scenario right now. A lot of websites are getting launched. So in this scenario, do you think it'll be feasible for a system admin to come up with a program that we had discussed, like a simple if and else kind of a program? Do you think it's feasible? I'm not sure if you guys understood the situation. Not at all, right? So I'm getting a lot of answers. I need to scroll also on my phone because new answers are not coming. I need to scroll. That's how it is. Anyway, just a second. Sorry, I missed. So yeah, so that is how it is. Now this is where machine learning can play a very important role. So what we'll be doing is, say we have a data which looks something like this, Okay, even before I get into that, one thing that you need to keep in your mind is machine learning is used for prediction. At the end of the day, what machine learning will help us do is it will help us predict something. So what predictions we do, we will discuss that. But at the end of the day, machine learning will help us predict. Okay. Now just think of it. Say I have a data something like this: website name, description, what exactly it has, and say I have few more columns which says the size of the website, number of pictures on the website, number of videos on the website, number of charts on the website, what kind of pictures, what is the quality of the website. I have a lot of details about the website. At the end, I also have one more column which says allow. which is yes or no. If it's yes, basically allow that particular website on your network. If it's no, don't allow that particular website on your network. As simple as this. Say if I have a data set like this, with the help of machine learning model, with this data, I can train my model. What is training? I will explain you that. But just try understanding this. I will come up with a machine learning model where I will give this kind of a data to the model. Say I train the model on 1,000 rows. Right now on this particular slide, you can see probably 15 to 20 websites, I believe. But then say I am training my model on 1,000 rows along with this data, which is allow yes, no, yes, no, yes, no kind of a thing. Now, after training the model, if a new website comes in, our machine learning model will be able to predict whether to allow this particular site or not. Okay, that's the whole point of machine learning. You can actually predict whether a particular website is allowed or not with the help of machine learning. Now, no matter how many thousands of websites keep coming up every minute, we don't have to worry because we are not writing rules right now. In the previous example, we were writing rules. If URL is this, allow. If URL is that, don't allow. So we had to write rules. But once you come up with a machine learning model, you don't have to write rules anymore. Okay, tell me, are you understanding what am I trying to tell you? I just want to explain you a simple scenario, a same task which can be automated, kind of automated with the help of machine learning. Yes? Okay. So now let's go back to this particular definition. Now try understanding. First of all, as I told you, machine learning is a sub-function, or we call it as an application of artificial intelligence, which we have already seen from this picture. Apart from that, it provides the ability to automatically learn and improve from the experience without being explicitly programmed. So even if new websites keep coming up, we need not explicitly program it. We do not write rules over here. Automatically, it has learned what to allow and what not to allow. And it will keep improving. As in how we keep using it, it will keep improving itself. This is actually an optional thing, but it can be incorporated. But mostly we don't follow this automatically improving. Okay, but yes, it can be done. So tell me if you have understood until here, guys. Before I proceed, I just wanted to check. Tell me if you have understood until here. Yes. Okay, I'm getting a couple of yes messages. Okay, great. Now, basically, I was talking about rule-based versus machine learning approach. What is a rule-based approach, and how can we transform that rule-based approach into a machine learning approach? So this was one of the simplest examples that I could probably think of. Now, this is how it is. So if it's a rule-based, you have conditions. Basically, you need to write rules. If URL equals this or that, whatever it is, you need to write rules. Here, what we do is we have training data, which is a data something like this, a data something like this. And you just give it to your machine learning model, and your model, if the new data comes in, we need not worry because our model will perform the prediction. And this prediction can be of any sort. We will come to that. We will discuss about predictions. But yes, this is the machine learning approach, whereas this is the traditional approach that we always had. How it improves itself, because it'll be automatically learning. I'm getting this question from Aditya. How does it improve? Say if a new data comes in, this new data was not part of the original training data. So with the original training data, our model has learned something. But say if a new data comes in, which was not present in the training data, it will consider this also as a part of the training data before the next prediction. In that case, every time a new data keeps coming in, it will keep training itself. So that is how it can improve, as and how we progress. So did that answer your question, Aditya? Okay, guys, tell me what comes to your mind when you look at this particular picture. I mean, there are two different pictures over here, one on the left and one on the right. So tell me what comes to your mind. I need to keep checking my phone. Where 21 people, sorry. Self-study versus college school. Okay, that's a good answer. Online and offline. No, no. Okay, self-study and what was the answer? College versus school. This is something that I was actually looking for. So here the person on the left is doing a self-study, whereas over here the person on the right, I mean, these students have someone over here as a mentor or an instructor, whatever it is. I don't know which one do you think is effective. A lot of people prefer self-studying. A lot of people prefer some mentor for them. So it depends from individual to individual. But this actually resembles something, which is, say, if you are doing a self-study, it's not very easy for you. At the same time, it's effective. I understand that. But say it's not going to be as easy as having a mentor for yourself. You guys will agree with me for that. So it's not going to be that easy, because if you have a mentor, you will have, say, something like, say, let's consider a very simple scenario. Say if this particular person is studying A for apple, B for ball, C for cat, D for dog, something as simple as that. I know it sounds stupid, but then just to understand situation. So here, if you have a mentor will show it to you. This is an apple, this is a ball, this is a cat, this is a dog. So somebody's telling us what are these. On the other hand, you will have to figure out what are these if you're doing a self-study. So here, if you have a mentor or someone, there's someone who's telling you what are these. Okay, so this actually resembles, there are two different types of machine learning. One is supervised learning and the other one is unsupervised learning. Let me explain you that with the help of this. So if you have a data set like this, so here, this particular last column, which is say allow yes or no, something that we are actually predicting. So this, we call this particular column as our target variable. Target variable is something that you will be actually predicting. So if you are predicting something, if you have a target variable, it's called as a supervised machine learning model. If you don't have a target variable, then it's called as a unsupervised machine learning model. I will come to these things in a little more detail, but right now, okay, I have one more picture to show to you. Probably that will help you a lot. So this, somebody who's helping you. See, this is apple, banana, whatever it is. Somebody is helping you. If somebody is there, basically, if we have labels, if you have a target variable, in that case, it's a supervised learning. On the other side, if you are trying to figure out, if the model is trying to figure out everything by itself, then it's a unsupervised learning. Okay, self-study, yeah. Tell me if you have understood until here before I proceed to the next topic. I mean, I'll be talking about supervised and unsupervised a little more, but tell me if you guys have understood until here. Okay, can I keep my phone somewhere? Sure. Okay. Okay, so this is, these are the subdivisions of machine learning: supervised, unsupervised. Apart from these, we have few more, like, we have something called as semi-supervised. We have reinforcement learning. We have deep learning. Deep learning is actually got to do with neural networks, and neural networks, usually people call neural networks as artificial intelligence. So any project which involves neural networks is artificial intelligence, but actually anything that you're talking about machine learning is representing artificial intelligence, because if you look at the definition also, machine learning is an application of AI, right? So yeah, back to these topics. So we have supervised learning, unsupervised learning, reinforcement learning, semi-supervised learning, deep learning. We have few of these types. So let's get into details of these. So if you look at the definition supervised learning, again, when you Google for these kind of terminologies, you're gonna get big definitions, and it's gonna be a little confusing. That's why I have tried keeping it as simple as possible. This happens, it occurs when an algorithm learns from the example data. Basically, when you have a target variable. And this happens when the algorithm learns from the plain data. When I say plain data, there is no target variable which is present. What is deep learning? Okay, I've got a question from Amog. What is deep learning? So deep learning, uh, Deep learning basically involves neural networks, guys. So it's a complete different topic, but then it's again a subdivision of machine learning. So deep learning and machine learning are not two different things. There are actually, as I told you, deep learning is a sub part of machine learning. Things which regular machine learning algorithms fail to perform, deep learning algorithms will do it better. For instance, anything got to do with, say, images, regular machine learning algorithms will not work very well with the images. But when it comes to deep learning architectures, like, say ANN for that matter, or CNN for that matter, RNN also, but then CNN is actually good for image processing. So basically, yes, the whole point is there are a couple of tasks, couple of challenges which regular machine learning algorithms cannot do very well. In that case, we will have to go to deep learning. Okay, so yes, that is what it is. Okay, tell me what comes to your mind when you probably look at this picture. I have got answers from students saying it's my 10th mass card, it's my 12th mass card. So tell me, there are two different pictures over here. So do you see any difference between the mass card on the top and the mass card below? Do you see any difference? Okay, what is the difference, Omkar? Anybody can answer. Anybody who is willing to answer can answer. What difference do you see? Very good. One has grades and the other one has marks. So if you look at the top one, it has marks, whereas this has grades. Correct? So now I want to talk about one topic called as continuous values and discrete set of values. In simple mathematical maths terminologies, when you say continuous value, you have a big range and your value can be anything from that range. So basically a very big range. But when you say a discrete set, you have only fewer values to select from. For instance, if I'm talking about, say, marks, so my range is from 1 to 100. So I have 100 different possibilities over here. In fact, if you consider decimals, like 50.51 is one possibility, 50.52 is one more possibility. In that case, we will have few thousands of possibilities here. Whereas in this case, say we have grades from A, B, C, D, E, that's all five. Then we have only five different possibilities, right? I'll tell you what am I trying to explain. I know this might look a little random to you guys. I'll tell you. So if your target variable, first of all, supervised machine learning algorithms involves target variable. This is something that you need to keep in mind. Now, if your target variable is a continuous value, if your target variable is a continuous value, then you have actually something called as regression problem. If your target variable is a classification, sorry, if your target variable is a discrete set, very few possibilities, in that case, you have a classification machine learning problem. Again, as I told you, machine learning is divided into supervised and unsupervised. Again, supervised learning has subdivisions, which is regression and classification. Regression, first of all, it needs to have a target variable. If your target variable is a continuous value, in that case, it's a regression problem. If your target variable is a categorical, when I say categorical, basically I'm talking about discrete values. In that case, it's called as classification problem. Tell me if you have understood until here before I proceed. What's the time right now? 43. Guys, have you understood until here? I'll have to keep checking my phone, guys. I'm not getting a yes probably from everyone. I have like 20 students over here. I hope all of you are understanding, and please ask me questions. If you're not understanding anything, I'll be more than happy to answer your queries. Okay, so yes, regression and classification is something that I wanted to explain you. Now, again, there is unsupervised algorithm. Okay, you can look at this particular picture also. So say if you have a student's profile as your data, and if it's helping you predict pass or fail, what kind of a range will this belong, pass or fail? Is it continuous value or is it a discrete value? Just look at this, pass or fail, only two different values. In that case, what do you think it belongs to? Discrete, right? So in that case, if it's a discrete value, then it's a classification problem. Okay, if it's a percentage, when I say percentage, again, it's a numerical value. It can be of a very good, I mean, it can be varying. I mean, it has a big range, right? Basically, uh, percentage can be 50.33, 70.77, 83.90, whatever it is. It's the range is big. In that case, it's a regression problem. It's a continuous value. Okay, so this is something that I want to explain you before I move to steps. As I told you, again, there are a lot of things, but because of the time constraint, I have to choose whatever is important, whatever I feel is important right now. And these things I felt are really important for you guys to understand before you start your journey in the field of machine learning. So what are the steps that we usually tend to follow whenever you're building a machine learning model? First of all, as I told you, machine learning is used for prediction. You will be able to predict something with the help of machine learning. So now, obviously for prediction, we need to train our model. Again, for training, we need data. So first, get the data, train your model, start predicting, and then you can finally deploy a model. Once you deploy a model, other people can use your model for prediction. So this is on a very high level, but this is what people think is machine learning. Get the data, train the model, predict, and finally, if it's happening correctly, just deploy the model. So this is how people usually see machine learning as, but then the reality is a little different than that. Okay, I will speak about the reality now. But yes, tell me, have you guys understood until here? Just can you just put a simple yes if you can proceed from here? Okay, excellent. Okay, before I speak about the reality, I have a simple exercise for you guys. I have four different data sets here. Insurance data set, rainfall data set, telecom. When I say telco, it's a telecom data set, gold rate data set. Let's go one at a time. So if I have insurance data set, purple color one is the data set, red color one is my target variable. First tell me, is this a supervised, let's consider this first data set, insurance. Is this a supervised machine learning model or unsupervised machine learning model? What do you think is this? Amok says supervised, okay. Seema says supervised, Nikhil says supervised. Supervised, correct. It's a supervised model. What makes you say that? Because we have a target variable. If you have a target variable, something that you'll be predicting, then in simple terms, it's a supervised model. Now, again, supervised has division. What kind of a supervised model do you think this is? When I have to predict the insurance amount, in that case, what kind of a model do you think this is? Regression, continuous. If you have continuous values, so what is it? Regression, correct. So it's a regression supervised machine learning model. Okay. Now just use common sense. Just give it a thought. If I have an insurance data set, if I have to predict the insurance amount, if I have to train my model on this data, what do you think I can actually exclude from the data? What do you think is not required for me to train in order to predict the insurance amount? I have age, marital status, employed, height, weight, school, college. What do you think is not required for me from this data? School or college, okay. Height and weight, okay. Say this is a health insurance. In that case, height and weight might matter because with the help of this, we can get to know if the person was actually healthy or not. Like basically, you can find out if the person was obese or very slim, very lean, whatever it is. With the help of height and weight, you can find out that. So, but definitely school and college. Do you think it's required, school and college? It's definitely not required. Employed, at least we might require this because say the insurance amount is a little high if the person was not employed. If the person is employed, it depends. So this in this particular data set, school and college are definitely not required. coming to this particular data set, which is rainfall. First, tell me, is this a regression or a classification? If you have to predict the amount of rainfall, in that case, is it a regression or a classification problem? I'll have to keep checking my phone. I'm talking about this rainfall data set right now. No answer. What do you think is this, guys? Regression, correct. It's a regression problem. Same question over here again. Which column do you think is not required for me from this particular data set? Number of people, very good. So definitely number of people is not required. In order to predict the rainfall, amount of rainfall, temperature, humidity, date, time, soil, these things matter. But number of people in that particular village, I don't think so it's required. Right? So it's definitely not required. Okay, let's go to this next data set, which is telecom. Churn is nothing but churn means whether the person left the company or not, yes or no kind of a thing. So tell me, is this problem a classification problem or a regression problem? If you have to predict the churn of the customer. Classification, very good. It's a classification problem because we will have to predict whether the person will leave or not leave. Will churn or not churn, yes or no, 1 or 0, very small set, discrete value, discrete values, discrete set. So it's a classification problem. Now tell me what is not important from your. Loki says height and weight. Okay. Anybody else with a different answer? Data usage is important for a telecom company. In telecom company, it's really important. But height and weight, as Logesh is also pointing out, it's definitely not required. So say if you are in a Vodafone network and you want to switch to Airtel, you send a simple message saying port whatever it is. Now, once the Vodafone gets that message, they will allocate a representative. The representative will call you and give you better offers, whatever it is. So that is how it goes, right? I'm pretty sure whoever has tried porting, you guys have witnessed the situation where they will try contacting you in order to retain you so that you don't churn from their company, right? So obviously, do you think height and weight matters at that point? What is the height of the person? What's the weight of that particular customer? It doesn't matter, right? So yes, the other things maybe it's required. Let's come to the last one, which is gold rate. Now, in order to predict the gold rate, what do you think is not required? This is a little tricky one. This is a little tricky one. Just try telling me which one do you think is not required? Item. Very good. So in order to predict the gold rate, whether the item was a ring or a earring or a necklace or a bracelet, it's not required because gold is gold. Item doesn't really matter, right? So if you just give it a thought, item is not required. Okay. So with the help of this, what I tried explaining you was, now whatever you guys just did, telling me which feature, all these are features. Age is a feature, marital status is a feature, employed, height, weight, school, all these are features in this particular data set. So in every data set, you guys tried selecting features which are relevant. So this is one of the steps in building machine learning model, which is called as feature selection. Feature selection is something that we guys just did. And in every machine learning model, this is one of the typical thing that we need to do. I'm not explaining you all these steps. I'm explaining you whatever is possible. Feature selection is one. Let me give you an example of one more thing, which is in order to predict the gold rate, I have total grams, which is not required for me. I want gross weight, actual weight of the gold, which is actually not given over here. I have stone weight, I have wastage, I have total grams. How can I derive gross weight, actual weight of the gold with the help of these? How do you think I can do that? A simple formula. Any idea, guys? Subtract wastage, correct. I have total grams, I'll just remove the wastage and the stone weight. With the help of that, I'll be able to get the actual weight which is required for me in order to predict the gold rate, right? So right now what I just did is called as feature engineering, which is, say you require a feature in a data set which is not available. In that case, you will use existing features in order to come up with a new feature. So that is called as feature engineering. Okay, so I just want to explain you feature selection and feature engineering. So if you look at the actual steps for machine learning, for building machine learning model, this is how it might look like. So you have a problem statement, you need to understand the business. Once you do that, you'll have to get the data, you'll have to clean the data, perform feature selection, engineering, normalization, standardization. There's so many different things that can be done. And then you choose an appropriate algorithm. So what bifurcation we have seen is AI, inside which we have machine learning. Machine learning has supervised, unsupervised, semi-supervised, so many things. Let's consider supervised. Now supervised has regression, classification. Now again, regression has few algorithms, classification have few algorithms. For instance, if I consider classification, KNN is one of the algorithm, logistic regression is one of the algorithm, uh, random forest is one of the algorithm. There's so many algorithms when it comes to classification. You need to select an appropriate algorithm depending on what kind of a data you have, what kind of a target variable you have, what kind of a spread you have. Depending on all of that, you'll have to select the appropriate algorithm, and then you will have to train your model. Because you have the data, a clean data, you will train your model. Once you train your model, you need to check if the model is doing very well or not. So basically for that, you need to check the accuracy of the model. Very important. So if the accuracy is less, actually you go back, you clean the data, you choose a different algorithm, you train the model, you come back again. So somehow you'll have to get a very good accuracy. If this is happening, you finally start predicting and you will deploy your model. Tell me if you have understood this on a very high level. What is the time right now? 56. Guys, have you understood this until here? Call messages. Any questions? I have not got a lot of questions. I was expecting a lot of questions from you guys. I have not got a lot of questions. How can we code all these things? Amok, to show you that, the next slide, if you just look at, it says, let's get into some code. I will show you some coding. Obviously, I won't be coding everything from scratch. I can do that, but then it's going to be time consuming. I have another 15-20 minutes maybe. So I'll just, on a very high level, I'll just show you how things are done. Okay, how many of you are good with Python? Just good. You don't have to be amazing with Python. How many of you are just good? Like if I show you the code, you will try to understand, yes, this is where a library import is happening, all of that. A little bit. Ansika says me. Okay, Ansika is good with Python. What about the other people, guys? Because if not, I will try explaining the code also somehow. Seema is good. Logi says yes. I want to know basics of and the advanced. Okay, Omkar says that. Okay, so let me start my Jupyter. Jupyter, if you guys are not aware, Jupyter a notebook is one of the IDE available for Python in order to do projects on machine learning, just like how we have Eclipse for Java, Visual Studio for .NET developers. Similarly, for when it comes to Python, we have PyCharm, we have IDLE, we have Visual Code, we have Jupyter. So for machine learning projects, data visualization, data analytics project, people usually prefer Jupyter Notebook. So let me just show you one. Say, let me take up this ML batch algorithms. I'll just show you how things are done. So let me take one example, which is for KNN. Okay, I'm not going to get into details of KNN algorithm. How is it actually done? I will not get into that because again, time is, I mean, first year, I'm just importing libraries. Okay, this is Iris dataset. Let me take any other algorithm, which is, okay, support vector machines, SVMs. So I'm just importing over here. I will read a data set, which is from a telecom. We have seen a telecom example, right? So I'm reading a data set like that, which has a target variable, which is exited, 1 or 0. 1 means, the person has left the company. 0 means the person has not left the company. So I have a data set. It's not only 5 rows. I have a lot of rows. It's just that I'm not displaying all of these. So if you want, let me just show it to you. So I have somewhere close to, yeah, I have seen that over here. So I have somewhere close to 10,000 rows in this. So these are the columns that I have: customer ID, surname, credit score, geography, gender, age, tenure, balance, number of products, has credit card, is an active member, estimated salary, exited. Okay, guys, just look at this particular, these features. Now you guys do a feature selection. What is not required from this in order to train my model? So for feature selection, what do you think is not required for me in order to predict whether the customer will, whether the particular person will leave the company or not? Can you guys quickly take a guess? These are my columns: row number, customer ID, age important, age is important, salary also important. Say if a person has a very low salary, it's very likely that the person might leave the company if it's expensive or whatever it is. Salary important, age is also important. Young people tend to switch companies a lot. See, older people, they might not try porting to another company. So age also actually matters. Geography also matters because network depends from one geography to other geography. Say Vodafone is good in Bangalore, not necessarily it'll be good in Hyderabad as well. So geography also matters a lot. Balance again matters. Surname, very good. Surname, do you think surname will matter when I'm training my model? Say if a person has the name Patel, uh, is there, I cannot conclude saying if a person has name Patel, it's very likely that this particular person might leave the company or not leave the company for that matter. Or if a person say has Garg in the name, not necessary that the person will leave or not leave. So surname is definitely not required. Can you tell me a few more things which are not required? There are a couple of more algorithms which are not required from this. If you guys can just guess quickly. Gender, very good. Gender, it's kind of neutral. We'll have to do some more things in order to find out whether gender is actually required or not. It could be important, it could not be important. We will have to do a few more analysis. So we can't just look at the column heading and find out. But yes, sometimes it's not required, sometimes it's required. But row number, do you think row number is important? Customer ID, do you think customer ID, can we say customer with the IDs 100 or 101, 102 will not leave the company? We can't say that. It's just a customer ID that company has given them. So row number not important, customer ID not important, surname not important, gender we need to perform few more analysis. Apart from that, everything else I feel is important. So this was a simple feature selection that I just did. Has credit card? Yes, it could be important because if a person has credit card, say even if the balance is low, with the help of credit card, he will pay the bills or he will not pay the bill, whatever it is. With the help of has credit card, it is kind of, I mean, it can be used. So here I do a simple feature selection. So this is my feature selection. I need to have my input variables and I need to have my target variable. So this is my target variable, which is exited. This is something that I'll be predicting. After that, I do a simple split in the data. I will split the data into training data and the testing data. After I do that, I will simply import the algorithm from my sklearn library. Sklearn is one of the most popular library when it comes to machine learning because it has all the algorithms inbuilt. So you don't have to code all the algorithms from scratch. So you can just import the algorithm and you can train the algorithm. When I'm calling this fit function, when I'm passing this data, fit function is actually used for training. So this is my input, this is my target variable. So I'm just training my data over here. How does this algorithm work? That depends. That's the story for another day maybe. So yes, every algorithm have their own approaches in finding out. After that, I simply evaluate what is the accuracy, what is the precision, recall. All these things are basically used how well our model is doing. Okay, so yes, this is what it is. Kernel, this is a part of SVC algorithm. You don't have to worry right now. Kernel is, with the help of kernel, you'll be raising your data set into a higher dimension. This is specific to this particular algorithm. It's not there for all the algorithms, so you don't have to worry on this. Okay, so yes, this is what I just wanted to show you. In fact, if you want, I have one more project. I'm not really sure if I have it right now. I can perform a simple prediction and I can show it to you. Let me try doing that, because I had deployed a simple project. I had created a code, machine learning code. I had deployed that already. Let's see if I have that. Web churn. So this is a web application in which I have my machine learning model. Let me see if it's still working. I had written this code long back. Okay, this is one of the churn predictions. So you just give your inputs. Senior citizen, yes. Partner, I'm not sure if this is working or not. Tenure, say for 6, has phone service, has multiple lines. I'm just giving inputs in order to predict whether this particular person will leave or not, will churn from the company or not. Am I getting any questions? No, right? Streaming TV, streaming movies. I'll tell you the application also of this. Monthly charge, say 100, total charges 1000, something, some random. After doing all of these, I will predict. This is one of the algorithm that I've used, which is decision tree. With the help of decision tree, it says, yes, with whatever inputs I gave, this particular person will leave the company in the near future. Okay, now just try understanding this. Let me stop sharing my screen for some time. Just try understanding this. If say there's a Vodafone company, let me take the same example. Can you show the code of the web? I will show you something just sometime. So say I have this Vodafone company or Airtel company, whatever company it is. If I have the data already of the people who have already left the company, of the people who are whom I could retain in the company, whatever it is, if I have that particular data, and say I build a machine learning model which is 95% accurate. You check the accuracy of that particular model, it's 95% accurate. Now with the help of that, you can actually predict for that particular company who will leave, who will churn from that company. Don't you think it's important? Say for a Vodafone company, if the company is already able to predict, say in this particular month, in this next month, in the month of November, 5,000 people are about to leave the company. If they're able to predict that, don't you think they will start giving better offers to them? They will reduce their tariffs. They will try giving discounts to them. So if they can help, if a machine learning model can help them predict these particular people are about to leave the company, obviously it's everything for them. They will try doing everything in order to retain the customer. So they are actually avoiding some business loss. So revenue will continue coming. They will not lose out on revenue. So there are so many things. I'm just giving you one simple example, because with the help of machine learning, if your machine learning model can help you predict something which can happen in the near future, it's all that you guys want, right? So yes. Okay, I was planning for a few more things, but then I think I wanted to show you code from the scratch, but then it's going to be time consuming. So I just showed you how can we deploy. Aditya, for deployment, there are different pipelines altogether. Nowadays, we have something called as ML ops. ML ops is you automate your entire pipeline of how do you deploy. How I have deployed is one of the simplest technique that I've used. There is something called as pickling. So once you train your model, which is sure, let me try sharing screen again. So once you train your model, and somebody was asking me to show the code, right? So once you train your model, which is here, this is my trained model. After I tried fitting, this SVC is my trained model. After training the model, you can actually pickle this particular model. When I say pickle, you save it, just like how when you're playing Xbox or say PlayStation, whatever it is. If you're playing, after some progress, you save your game, right? Similarly, you can save until there, so that the next time you come back, you can continue from there. The reason why we do this is, if you're working on very large data, basically if it's a distributed data, say Hadoop, it's distributed over Hadoop architecture. In that case, training itself will take hours together. After training your machine learning model probably for some 4 hours or 5 hours, next day when you come back and you want to predict something with that particular model that you have trained, you don't want to go through the entire pain process again of training the model. So you don't want to spend 3 hours and 4 hours sitting back on your system in order to in order to train your model. So what you can do is, after training, you can convert that into a pickle file. Once you convert that into a pickle file, the next time you come back, you need to just unpickle it and you can start predicting. One of the simplest way of deployment, people usually don't follow this approach when it comes to production systems, but yes, this is one of the simplest technique. So I've already pickled a model. So once I get the inputs from the people on all these things, gender, senior citizen, and all of that, I will simply unpickle my model. I've already pickled and I've kept it over here. So I will just unpickle my model and I will start predicting. Okay, but in production systems, there are good pipelines available already. So mostly it's going to be on cloud. A lot of companies are following auto ML, which is, performing machine learning on the cloud. So that is the trend right now. So today we are using Python 2. No. Python 2 was stopped 12 years ago. So 2008, Python 3 was launched, and since then everyone's using Python 3. So whatever code you saw, it's probably from 3.7 or 3.8 version of Python. Can I code ML in any other language also? So right now the famous languages are Python, R language, Julia. There's one new language coming up. Not coming up again. Julia is 10-year-old. Probably it came into existence in the year 2009, but it's getting the fame now from past 1 or 2 years, and people have started using Julia. In a lot of parameters, it's better than Python, is what people claim. I have not used Julia at any point, but yes, Julia is one more. So on a very high level, Python, R, and Julia, I can say. You can do it on Django also. Sorry, not Django, sorry. You can do it on Java also, but it's going to be difficult with Java. Aditya is asking, you have used Django. For that web application, yes, I've used Django framework. Can you show the web churn code? I've shown already. Guys, any other questions that you guys have that you want to ask me right now? Anything got to do with machine learning, AI, or the career opportunity, whatever it is. Omkar, sorry, what was your question? Prologue what? Okay, no questions. If there are no questions, I think we are good to go. Do you teach deep learning? If yes, where? You can check my LinkedIn profile. You will get to know everything where I have my webinars and all of that. I keep putting my information on my LinkedIn. I work with Django, so please tell me any source where we deploy. Aditya, even if you're using Django for that matter, if you see, first of all, machine learning model are not always deployed on a web application. So deployment can be on any other application. It can be a sole machine learning project altogether without any web application. So if you're using web application, that was one of the easiest way. It's kind of complicated. I cannot just explain you in 5 minutes, but then there are good number of pipelines available. So if you want to know the details, you can contact me later. I will try helping you with that. Okay. Practicing data science and then making a jump to cloud. Would that be good, or should we focus on only one tech? ML patch Marine, yes. As of now, Vezio is where I'm taking classes. Yeah. Practicing data science and then making a jump to cloud, would that be a good? Earlier there were two different options. Even now we have two different, like, data science, machine learning is one part, cloud is one more technology. But then nowadays these things are merging because every company is actually going into cloud. So even if you, when you have data science projects or machine learning project, whatever it is, they'll be deployed on the cloud. So I think it's a good option, Mohammed Afahdin, that you can get started in data science and then move to cloud. Because if you have this on your resume saying you have a knowledge of machine learning and you know how to deploy it on the cloud as well, you can play around with GCP or Azure for that matter, AWS for that matter. If you have a knowledge of these things, it's going to be very good. How is RNN different from ANN and CNN? It's a very uh, broad question, Logesh. ANN is a simple neural network, not meant for images on a very high level. It's pretty simple. It's used for regression and classification kind of problems. CNN, on the other hand, is usually used for images. If your data set has images, you go for CNN. RNN, when you have forecasting, time series forecasting, in that case, you go for RNN. Okay, I hope I answered that question as well. Is there any classes going on for AI? I mean, there are classes going on, I believe. I mean, from my side, yes, I do conduct few batches here and there. It happens. Okay, guys, I think that's all that we have for the day. Tell me, did you enjoy this session? Did you learn anything new from this session? Yes, no? I just put my LinkedIn ID. If you guys want to connect with me, you guys can connect with me over here. I'm not sure if it's Aqib underscore, sorry, Ahmed underscore Aqib or Ahmed hyphen Aqib. Just cross check once. So yes, okay. So if you guys have learned something, that's more than enough. That's the end motive. I want my students to learn at the same time enjoy my sessions. So if you guys had that thing today, so that's more than enough. I'm satisfied. Okay, chalo, that's all from my side, guys. Thank you so much. Do we have Arpit over here?
Yes, sir. Yes.
Okay, Arpit, that's all from my side. So if you have any message to convey at the end, you can probably do it now. Okay, thank you so much, guys.
Thank you.
Thank you.
So, thank you everyone for attending the session and for your awesome interaction with sir. Also, my special thanks and regards to Aqib sir for giving his precious time and taking this wonderful session with us. It was a great learning opportunity for all of us, and that's for sure. Also, we would be sharing a feedback
People are
form in
saying my
the
LinkedIn profile is not available.
WhatsApp.
Sorry, I mean, yeah, guys, it's this one. Aqib Ahmed underscore, not underscore, hyphen Aqib. Yeah, that's my LinkedIn profile. Okay, that's all from my side. Yes, Arpit, sorry, go on. Sorry for interrupting. Yeah.
Yeah, we would be sharing a feedback form in the WhatsApp group for the students. So please do fill it, and you will all receive your certificates when you will fill the form within 2 to 3 days of it. So that was all from our side. Thank you all for joining.
Thank you, guys. Thank you so much. Hope to see you soon. Thank you. Bye bye. Have a good weekend ahead. Bye.